We fortunately have a bit of a break from deep quantum math stuff to talk about philosophy again.
Yay!
The first post is Where Philosophy Meets Science. I'll just go ahead and read this first little chunk that I pulled out.
Yeah, get us started here.
Okay. The whole conceit of this series of posts is that he is writing from a alternate timeline, maybe that knows what quantum physics actually is, and is looking back on the history of how people went wrong. He says that early scientists forgot that they themselves were made out of particles. They didn't notice that knowing about the electron's history was an example of particles in different places. It's much more intuitive, it feels simpler, to think about someone knowing something, rather than thinking about the brain's particles occupying a different state. Ancient physicists found it natural to think, I know where the photon was, what difference could that make? Not, my brain's particles' current state correlates to the photon's history, what difference could that make?
I like how you said that he's taking this from like an alternate history where we're viewing this from a different lens. He's just taking it from the current view now, right?
Yeah.
He's taking it not an alternate history. He's looking at history through today's lenses. If we knew what we knew today, they wouldn't have gone wrong in this direction.
Yes, but through today's lenses where everybody has more or less agreed that multiple worlds, spoiler alert, this is going with the multiple worlds interpretation, that multiple worlds is how quantum physics is best explained, and there's nobody still holding out to older, more wrong interpretations.
Gotcha.
And therefore, this sort of observation feels kind of obvious to them, whereas it still doesn't to a lot of people in the current world.
Yeah. Okay, yeah, that makes sense.
This is a thing that certainly didn't occur to me when I was reading about quantum physics in my early 20s. Like, correct me if I'm wrong here, but I also, even to this day intuitively, think of my knowledge states as not being encoded in particles being in different locations. It feels like a completely separate thing, which is the same kind of thing that makes most people feel like that souls are a thing and that consciousness is a thing, because all of those are like somehow separate from particles being in different places within a skull, when really that's all they are. It's unintuitive to think of thoughts as that sort of thing.
Yeah, this is just classic reductionist world that we live in. It's not useful for me to think of my brain as a wave function or a set of particles that correlate to, or that of which states hold whatever, encode my beliefs and perceptions and stuff, right?
Yeah.
Like, no, I just think of my brain as meat. That is the useful level of abstraction for me. Maybe neurons,
Right.
but like I don't think of anything in terms of fundamental particles.
Right.
So it is more intuitive and feels, and I like how he puts feels in italics. It feels simpler, and I believe that links to Occam's razor. It feels simpler, and it actually is until you're doing quantum physics. To be clear, it doesn't make it right. Our brains actually are the bottom level stuff, but it's not useful to think of them. If I'm crossing the street, which I do frequently to go to the store that's down the road, I don't look at cars. I don't look at anything this way because I'm not a physicist, but I don't look at them as masses of particles, right? I look at them as dangerous, impending objects, right?
Yeah.
The level of which it's useful to interact with reality versus the way reality actually is.
The part that still feels weirdly foreign to me is thinking of the patterns of activations in my head as corresponding literally to particles moving to different places.
Yeah, I have that same sort of sense of weirdness if I could take it a level higher and just think of like my neurons. Like,
yeah.
It seems weird to think that like, oh, this neuron fires when I think of George W. Bush. Like that's nuts.
See, it's weird. That doesn't feel nearly as nuts to me. To me, like the whole pattern swirling in my head of neural activations feels like a thing that I can grasp. But then when I think that those patterns literally are just small particles moving from one place to a different place, that's where I'm like, whoa.
Yeah, it can be small, but
Give
then when
me another rip of that bong, man.
So neurons is small, but not so small that it gives you that whoa, huh?
Mm-hmm.
I can feel you there. It definitely adds a whole other layer because I don't like the word because it sounds like, I don't know, it sounds like vomiting, but I can grok a neuron, right?
Right.
But I can't grok my brain as a state of, particles.
Yeah. The important consideration that he pulls out based on that last quote is the question, is your theory of fundamental physics going to examine all the particles in a human brain and decide when those particles know something in order to compute the motions of particles? This is basically what interpretations that deal with observation being important have to contend with. That why your theory is now going to have to include something that looks at particles in humans' brain and decides when those particles know something or not. And that is a silly thing to have to include in a theory about how things move.
It would beg the necessary question of like, how could you tell? When do you know that these particles know something? What's weird is that
Right.
at some point they actually do, right?
Yeah. Yeah.
Yeah, that now I see where I've taken a sufficient bong rip to see that. Like I can understand that more intuitively on the level of a neuron, but when I think of that in terms of particles, like particles don't know anything, but you get enough of them together, and suddenly I know that the sky is blue.
Yeah. And that's a problem for a theory of motion. It shouldn't have to account for having an entire theory of knowledge in order to determine how things move. He does point out, though, that this comes down to a problem of philosophy rather than a problem of experimentation, because he says the early quantum scientists were doing all the right experiments. It was their interpretation that was off. And the problems of interpretation were not the result of their getting the statistics wrong. It seems that the insights they needed were philosophical ones. And yet, it wasn't professional philosophers who swooped in and solved the problem and cleared up the mystery and made everything normal again. It was, well, physicists.
Yeah, this is one of those cases where, and I don't know the history of quantum mechanics all that well, but I'm pretty sure the cutting edge discoveries in the physics departments weren't discussed in the philosophy departments yet. So it's like
Mm-hmm.
maybe philosophers jumping in at this stage could have helped. Maybe some collaboration would have sped this along, but that's not how it played out historically.
He said that even where one philosopher gets it right in advance, it's usually science that ends up telling us which philosopher is right, not the prior consensus of the philosophical community.
This is where, and I think he mentions Democritus, concluding that the world is made of atoms. Like he got it right, not by accident. He got it right by reason, but
Mm-hmm.
he didn't get it right scientifically. His thinking was you can only cut something in half so many times before it stops being that thing. That thing must be that is an atom. Did he deduce the reality of nature? Well, no, actually, because he didn't get quantum mechanics. But I don't know. I've always felt like he got an undue amount of credit for that insight. He didn't deserve no credit, but it's like he didn't figure out atoms.
Yeah.
He just figured that you couldn't cut something in half too many times, and he was right. If I have one gold atom and I cut it in half, I don't have two gold atoms.
Yeah.
I have a big fucking mess, and then two different atoms.
And maybe radiation and shit. Who knows?
Yeah.
Oh. The final thing I pulled out of here is him saying that philosophy is only practiced effectively from within a science. Otherwise, you get philosophers who are mainly speaking to other philosophers and not really doing anything. So, professional philosophers, in quotes, would be very, very wise to learn every scrap of relevant seeming science that they can possibly get their hands on. And he doesn't say this, but I'm pointing out that we generally don't get this. I used to really like philosophy. I think the sequences was one of the things that kind of pointed out to me that philosophers seem like they aren't doing very much.
I think it depends on the philosopher. Like Dan Dennett definitely is an example of a philosopher who grabbed all the relevant science he could get his hands on and used that to inform his philosophy. Nick Bostrom is another good example. It's not like these people don't exist. It's just that they aren't maybe the majority of philosophers. I don't know what the majority of philosophers are or what they do, what their numbers are like. Trying to do philosophy in the complete absence of science, just you're basically destined to get it wrong unless you're accidentally right, like Democritus.
Yeah.
I agree with that point. A philosopher is best served by learning everything they can, learning all the relevant science that they can. And
Yeah.
I would argue that scientists would be better equipped if they were to be somewhat versed in some of the relevant philosophy.
I do think that a scientist would be probably a bit better of a scientist if they had some philosophy. Like a good philosopher is basically just a scientist who has some philosophy thrown on top.
Well, we can't know true Scotsmen away like good philosophers, right? Unless
Can't we?
I mean, maybe we actually can, and we'll just say like, look, there aren't actually good philosophers. There's just modest scientists or something. But there's another line in here where he says, and this will seem like a domain of philosophy. It will seem to you that you must do philosophical thinking in order to sort out the confusion. An example that I think of philosophy that I think would make better scientists is Bayesian rationality. It at bottom, it's a philosophical framework. It's not the result of science.
Yeah.
Like it relies on axioms that you have to adopt, and that's your philosophical bedrock. Like at the bottom of every philosophy, you can keep asking why until you just say just because, just like you can with nature.
And yet,
At the end, it's like, well, why do I care about my positions being consistent, or why should I care about getting the right answer? At some point, there's just no answer to that, and you just say, well, that's what I care about. And given that I do, Bayesian rationality is the approach I want to have. Like,
yeah.
I don't think the framing of like philosophy or science is appropriate.
I strongly agree with you that basically Bayesian rationality is a philosophy, and yet I do think it's better for it not to think of itself as such and to think of it more as, decision theory or statistics or a way to inform how one does science, because it just seems like once you start thinking about something as a philosophy, it starts getting up its own butt instead of actually concentrating on the real world. And
Well,
but it's definitely a philosophy of how to interact with the real world in a way that leads you away from error.
right. And someone could push back and wonder, like, well, then why do I care about getting a worldviews that are free from error? And it's like, well, the point of this framework isn't to convince you of that. It's if you already want that. I want to toss out an example here of like, where do you think this falls? The domain of AI alignment.
Hmm.
I think it started as a philosophy and then moved into the realm of science after. Like it started out as philosophizing.
Sure. I'm going to go with like at the very earliest levels, yes. As he says, like at the most early levels, before there's any science we can do to something, all we have is philosophy. But I think it pretty quickly turned into study of decision theory, possibly with a little bit of programming thrown in.
That's fair, and that's sort of the answer I was thinking of. I don't know the timeline of how long it stayed in the realm of philosophy and not science or whatever, but I guess my thinking is that separating those two isn't necessarily useful. At the beginning, it just was a realization that wait, hold on, why would smart equal nice? And that's not a science question, at least
Yeah.
not when first asked. It's a philosophy question.
Hmm.
Things become philosophy after. He does wrap this up in a nice way that I really liked. He says, "This is not to say that there's no place for professional philosophers in the world. Some problems are so chaotic that there is no established place for them at all in the halls of science." Then I'll grab the last sentence, which says, "They should not be surprised at the prospect that experiment and not debate will finally settle an argument. They should not flinch away from running their own experiments if they can possibly think of it." And I totally agree with that.
Yeah.
Good philosophy should have experiments and should propose them.
And should try to become a science as quickly as it can.
Well, it's one of those things of like, when you try to make something a science, some people push back. Like Sam Harris wrote a book called what was his ethics book called? Basically, he's like utilitarianism. I'm taking that as the appropriate way to think about things, and he doesn't call it that. It's more broadly consequentialism. You have to just take as an axiom that the suffering of conscious beings is bad. If you don't believe that, then this isn't for you. People would point that as a weakness of the philosophy of his position, but it's at some point there is just bedrock.
I think that's one of those points that they didn't agree on until the Enlightenment. And when that culture swept through and took everything over, I don't think there was broad agreement among humans that suffering is bad, which
I
is
think
interesting, right?
I think you're probably right, and I mean, depending on how finely you want to dice that sentence, there's people who still disagree now. But I brought that up because I'm wondering what experiment could they possibly think of that would validate that position. When you grant enough axioms just to get your shoes tied so you can start moving, then it's possible to actually do experiments. Or look at natural experiments. Which societies fare better, the ones where girls are allowed to learn how to read, or the ones where they're not. And then, of course, like, what do you mean by better? I don't know. Who lives longer? Which of those cultures have more money and comfort?
One might ask which of those cultures still exists in a few hundred years and hasn't gone extinct due to not reproducing.
Right. Or which of those cultures has historically already gone extinct?
Yeah.
Those are some natural experiments you could run. This is interesting, and this will be the last thing I say on the point, just because otherwise I could spend all day, navel gazing at it. But I think you need to get a certain bedrock of philosophy going, and then you can start doing your science. And a lot of like I was going to say wasted philosophy time is spent arguing about the bedrock, but you do actually need that.
Okay.
But I think that there's a lot of contemporary stuff where it's like, look, guys, this is just settled, or it's settled enough that I'm going to move on. And if you guys figure out that no, it turns out it's actually never, ever, ever ethical to lie, then let me know. But I think Kant was wrong.
I do think he mentions in this post that there was a time where should we use the scientific method? Like even the scientific method was a question of philosophy, right? And eventually that became settled as like, actually, yeah, scientific method is the best way to learn about the world. But that was not a settled question for a long period of time. No,
yeah, of course. It had to be invented.
Yeah.
And I mean,
I think that's what you're saying about like having a foundation that we agree on.
Yeah. And that foundation can grow and expand. We've all read Method of Rationality. We remember him describing N-rays, the introduction to the scientific method of double blinding. Like that wasn't a thing 150 years ago. That's part of what makes this system so awesome, is that it is correcting. If there are, peer review was looked at for a long time as this awesomely important feature of it. And I think compelling arguments have been made recently that says, it was a good idea at the time, but it seems not to have borne fruit.
Mm-hmm.
And so maybe peer review will go out and we'll focus more on replication. Over time, the ratchet of science just gets better, more refined.
Yeah, I
And
think it does.
Part of one of its features is that it allows itself for that kind of modification.
Yeah.
If they had said, nope, we figured this out, we've settled it in 1675, this is how we're going to do science forever, and this is the best way to do it, they would fall behind people who decided they're not going to do science, they're going to do science 2.0.
Which is why they're not around anymore.
Yeah, and then they all died because they didn't solve Asian yet.
Shit. Oh, boy.
All right. Well, Eneasz, can you prove that two particles are identical?
As a matter of fact, I can.
Ooh.
Yeah, which is kind of interesting. Yeah, well, this is continuing his previous post about philosophy of science, because this kind of originally starts out as a philosophical question, which later turns into an empirical question. So he is using this, I think, as an example or as a follow-on from the previous blog post, previous sequence post.
Yeah.
He is talking with a philosopher named Bob and asks that philosopher if you can prove that two particles are identical. Not can you personally prove it, but in theory, in principle, is it even possible to prove that two particles are identical if you're a human? And Bob is saying no, because no matter how many experiments show that two particles are similar, tomorrow you might discover an experiment that distinguishes between them. They might have extra properties that we didn't know to look for, or differences that are too small for us to currently measure. Those things are conceivable, and therefore it's logically possible that such things could exist, and two particles that we thought we had proved were identical turn out not to be.
I love that as somebody with philosophical inclinations and favorings, that line of reasoning sounds persuasive. Eliezer politely points out that Bob isn't being stupid. He's right in any classical universe. And he's not just doing like this could be the matrix or the problem of induction or whatever. It's kind of problem of induction, but it's one level above that of just saying, look, it's just humble. It's properly humble to say we might discover a way to do this tomorrow.
You know what throws up the red flags for me nowadays? When Bob says conceivable and therefore logically possible.
Yes, I think we've had enough conversations that rely on conceivability in the last few months that have raised my attention to that as well. I need a lot more help after conceivability to believe that you've convinced me of anything.
And to believe that conceivable actually even means anything in the real world.
Right.
But as Eliezer points out, that he is right in a classical universe, but we don't live in a classical universe. Our ability to perform an experiment that tells us whether two particles are entirely identical actually goes right to the heart of what distinguishes the quantum from the classical. In this regard, this may be one of the most important posts in the quantum sequences, and is kind of what the previous several posts were building to. What it comes down to, why this actually is a thing that one can test if the world is quantum rather than classical, is, as Eliezer says, if you have a particle 1 and a particle 2, and it's possible in the experiment for both particle 1 and 2 to end up in either of two possible locations, I'm going to call them location A and B. He uses L1, L2, but A and B I think is simpler. Then the observed distribution of results will depend on whether particle 1 at A, particle 2 at B, and particle 1 at B, particle 2 at A is the same configuration or two distinct configurations. If they're the same configuration, then we add up the amplitudes flowing in. If they're different configurations, then we keep the amplitudes separate. And because of this property, we can actually test what happens. Do the amplitudes combine? Do we add them up? Or do we keep them separate? If we add them up, then two particles are identical. Particle 1 at A, particle 2 at B is the exact same thing as particle 1 at B, particle 2 at A, because there is no particle 1, particle 2, there's just electron in a fully general sense, or photon, or whatever. That is actually not covered in this post. That is covered later. I am jumping the gun here, but this post is asking the question, is it even possible to make this experiment to determine this? And in a quantum universe, actually, yes, there is. And that's how we know we're in a quantum universe, not a classical one.
Nice, yeah. Well summarized. And I mean, not to be negative Nancy on this, but I like these two posts because they weren't mathy.
Yeah.
We don't need a lot of diagrams to understand the meat of these.
Yeah, so Bob's problem, Bob assumed that particles are fundamentally real. and in the classical universe they are, but in our universe, the individual and fundamentally real entities are configurations of multiple particles, and the amplitude flows between them. Which means that actually quantum discoveries changed the whole nature of the game, from a world that was the sum of individual particles to a world that is the sum of amplitude flows between multi-particle configurations. I think that some interpretations still do not accept this, which is what makes the quantum sequences controversial.
Yeah, fair enough. And at least in my mind, the real point of the sequence isn't to teach you quantum mechanics. It's to teach you that reality is normal and you're weird. And
Yes.
if you find nature confusing, that's your problem, not nature's. To me, it doesn't really matter which version he's teaching. If he's teaching the one that everyone agreed now was wrong, then I would give that a huge asterisk and point that out. But I think that this is at least a popular view, if not the supermajority view.
I don't think it's the super majority view.
No, yeah, but I think it probably is over 50%. Although I'm not sure. Physicists will be able to weigh in better than I can. It's kind of fun though to think about, like, this does seem to be another point, like, where does philosophy meet science? Like, if you have physicists doing the same experiments, getting the same results, and disagreeing, what are they doing? Are they disagreeing philosophically or empirically?
I mean, almost certainly philosophically, right? Unless they're
Yeah.
unless they're criticizing the other person's methods.
Yeah, well, I'm saying in a circumstance where they're running the same tests and getting the same results.
Yeah.
And they think, no, it means this. Well, no, I think it means this. They're doing philosophy at that point. And
Yeah.
I think that's kind of where he wraps up here. He says that experiments falsify assumptions we can't even see.
I really like that. I don't think anybody really realized that one of our core assumptions is that particles are fundamentally real. Experiments can falsify an assumption that we didn't even realize we were making, that particles are real, you know?
Yes, that's a great point. I'm glad you highlighted that because, like, I was talking a bit before about philosophical bedrock and needing a foundation, especially when the foundation's been there for long enough. You stop thinking about it. You think this is just the way it is. And so when you get a result that falsifies one of your base assumptions,
Yeah.
you think
that wasn't even in the running to be falsified.
right. So you think, okay, well, something weird is going on, not something about my model was wrong. He says, bear this in mind the next time you're wondering whether mere empirical science might have something totally unexpected to say about some impossible seeming philosophical question.
Yeah. All right. Well, what do we got for next time?
3 of them next time. We've got classical configuration spaces, the quantum arena, and Feynman paths.
Yes. And these are very heavy on the math and the nitty gritty.
Yay!
And they have a lot of diagrams in them. So we are not going to cover very much of that at all. We'll give a very rough, non-detailed, non-technical summary of the posts as best as is our ability. And I know it's still going to take me way too much time, and I'm not looking forward to it. And then it's going to be kind of a shitty summary, but I'm going to do the best I can with the brain I got.
I think that's the best we can do. Like I said at the beginning of these, we're either going to read them all verbatim and put pictures of the diagrams in the show notes, or we're going to give them non-satisfactory summaries.
Yeah.
So that's where we're at.